All right, I'm going to show you a little video here about hypothesis testing. We're just learning hypothesis testing, so this video will help you understand the first couple steps of hypothesis testing for Chapter 8 in your statistics class, and also give you some of the vocabulary you need. Our goal here today is by the end of this lesson, students will understand the first two steps of traditional hypothesis testing and the following vocabulary. So we're going to start with statistical hypothesis. A statistical hypothesis is basically an educated guess or a conjecture that somebody makes. So, in this case, my example is, Mr. Felderman claims that the average age of West Delaware High School teachers is 38 years old. And he's going to use an alpha value of 0.05, which I'll explain later. So, statistical hypothesis, again, is just an educated guess or a conjecture that somebody's making. It could be about an average or a mean. It could be about a proportion. Maybe you want to take a guess at what percentage of the people that are going to vote for Hillary Clinton, for example. That could be a statistical conjecture, statistical hypothesis. Now, those statistical hypotheses are divided into two types, a null hypothesis and an alternative hypothesis. The symbol for null hypothesis is an H with a 0, H sub 0. The symbol for alternative hypothesis is H sub 1. A null hypothesis, null means none or 0. So what a null hypothesis will always say is that there's no change or there's no difference or something is the same. So when we write a null hypothesis, which in this case we're going to write H sub 0 instead of writing out the word null hypothesis, we're going to say that the average age being mu, the average of the entire population of all the teachers at West Delaware, is equal to 38 years old. So because the null hypothesis always says that something is equal or the same, you will always use an equal sign here in every section all the way through Chapter 8. Now the alternative hypothesis is going to tell you the opposite of that. So in this case, the alternative hypothesis, which we symbolize using H sub 1, is going to say that the average age, mu, is not equal to 38 years old. Now the alternative hypothesis is important because the alternative hypothesis tells you whether this is a two-tailed test, a right-tailed test, or a left-tailed test. So you always look at this symbol to determine what type of test you're doing. Anytime that you see the not equals symbol, you know that it's a two-tailed test. Anytime you see the less than symbol, you know that it's a left-tailed test because it points left. That'll help you remember that. Anytime you see a greater than symbol that points to the right, you're going to be using a right-tailed test. So in this case, we're using a not equal symbol. So this is a two-tailed test. The other thing you always want to identify when you write out your null and alternative hypothesis is what is the claim? What is being claimed here? Well, in this case, Mr. Felderman is claiming that the average age of teachers at West Delaware High School is 38 years old. So I'm going to write parentheses claim here. The claim will not always be in the null. Sometimes it'll be in the alternative hypothesis. He could have just as easily claimed that the average age of teachers is not 38 years old. In that case, I would have written claim down here. Or he could have claimed that the average age of West Delaware teachers is less than 38 years old. So that could be a less than. Could have written claim here. Or he could claim that the average age of teachers at West Delaware is more than 38 years old, which means we would use a greater than here and put the claim down here. So there are a lot of different scenarios that could happen, but for right now we're going to go with that he's claiming that it's 38 years old. It's a two-tailed test, meaning that if we're thinking about this distribution, and I should also mention that we always assume the null is true. Just like a criminal is always assumed innocent until proven guilty, a null is always assumed true, unless we find evidence to show otherwise, not prove. You're really not proving in this case, but you're trying to get some evidence. So in this case, we're doing a two-tailed test, meaning that you're going to shade two tails. You're going to shade a tail down here and shade a tail down here. If it was a right-tailed test, you'd only shade the right tail. If it was a left-tailed test, you'd only shade the left tail. Now, we're using a significance level, 0.05. What that means is that the area of these two tails combined is 0.05. So half of 0.05 is 0.025 in the right tail and 0.025 in the left tail. So 5% of the area is outside in the tails, 95% of the area would be in here. This will look very similar to doing a 95% confidence interval. The next thing that happens is you go out and you take a sample mean. So you go out and you talk to 30 teachers and you say, how old are you, how old are you, and you get all 30 of them and you average those together. Now, we're assuming that the average age is 38 years old, because we're assuming the null is true. Let's say that we get a sample mean that isn't 38, right? Most of the time, when you go out and find a sample, you're going to have sampling error. Your actual sample is not completely representative of the true population. So what happens is you might get a sample mean that's right here. If that sample mean falls close enough to the hypothesized mean, then you're not going to reject his claim. Okay? And so this area right in here is called the non-rejection region. Or also called the non-critical region. The two tails then, this area and this area put together, would be called the rejection region, or also called the critical region. So the level of significance tells you how big those regions are going to be. Again, alpha is 0.05 in this case, so that means we have 2.5% in each half of the critical region. Critical value. Well, what we'll eventually be doing with hypothesis testing is figuring out what this value is here and actually finding a z-score here. So for example, you may already know, or you could look it up on a table, that when you have 95% of the area in the middle, our z-score is 1.96 and negative 1.96 over here. So what we would look at is, if we look at our x bar, we would convert that into a z-score and find out that if our x bar is more than 1.96 standard deviations from the hypothesized mean, so if it falls out here or out here, then we're going to reject this claim. But if we find an x bar that's less, like shown in my picture in this case, if it's less than 1.96 standard deviations from the mean, then we will not reject the claim. Now, I want to also talk about a couple other things here. I guess what I also need to talk about is what's a type 1 error? I forgot to write that up here in this case, but a type 1 error. A type 1 error occurs when the null is true, but you still reject it. So if this is true, we don't want to reject it, but what if we did reject it? That's called a type 1 error. And the probability of that happening is alpha, 0.05. A type 2 error in the other case is a different type of error. A type 2 error is where the null is not true and we don't reject it, right? If the null was not true, we should reject it. So if the null is not true and we don't reject it, that's also an error. That's called a type 2 error. And a type 2 error is actually represented by the Greek letter beta, which looks kind of like a cursive B. So that's kind of a rundown on the first couple steps of hypothesis testing. You should be able to do the first part of your 8-1 assignment at this point.